Good day, everyone. I'm Althea Torres, a computer engineering student, and in this video, I will be sharing my reflection on several important topics that I've learned from different YouTube videos. The videos I watch are chip manufacturing, why chip making is so hard, photolithography, how CPU is made, future trends of computer engineering profession. These videos gave me a deeper understanding of how chips and CPU are made, why the process is so complex, and what future technologies we, as future engineers, should look forward to. The first video, titled Chip Manufacturing, explained the detailed process of how chips, also known as integrated circuits, are made. It starts with silicon, which is taken from sun and purified until it becomes a perfect crystal. This silicon crystal is sliced into thin circular pieces called wafers. Then, each wafer goes through multiple complex steps, such as oxidation, etching, doping, and layering, to form billions of tiny transistors that act as the switches inside our devices. The video also shows how the entire process happens inside clean rooms, where workers wear protective suits to avoid contaminating the chips with dust or even a single particle, which can destroy an entire batch. After watching this video, I realized how much effort, accuracy, and teamwork are needed to create the small chip that power our gadgets today. I was amazed at how something that looks so simple on the outside is actually the results of hundreds of precise and careful steps. As a computer engineering student, this made me appreciate not just the software side of computing, but also the hardware side. How much dedication and science go into producing the tiny components that make technology possible. The next video, Why Chip Making is So Hard, discusses the reasons why the process of making microchips is extremely challenging. It mentioned that the main difficulty lies in the nanometer scale of modern chips. The components are so small that a single transistor can be smaller than a virus. To achieve this, manufacturing use highly advanced machines like EUV lithography systems, which cost hundreds of millions of dollars each. The video also explains the global aspect of chip production. Chips may be designed in one country, fabricated in another, and packed somewhere else. This makes the process not only technologically challenging, but also dependent on international cooperation. This video helped me understand that chip making is so hard not only because of technology, but also because of the complex coordination it requires. It involves multiple countries, industries, and experts all working together to make one product. It reminded me that as a future engineer, I should not always focus on technical skills, but also on collaboration, problem solving, and adaptability. Because the success of engineering projects depends on how well we work with others, even across borders. The third video is called photolithography. This process is one of the most important steps in chip manufacturing. The video explained that photolithography is the technique used to print the tiny patterns of circuits onto a silicon wafer using light. First, the wafer is coated with photoresist, a material sensitive to ultraviolet light. Then a mask containing the desired circuit pattern is placed above it. When UV light passes through, the pattern is transferred into wafer, creating the structure for the transistors and interconnections. This process is repeated multiple times to build many layers of circuits on a single chip. The video also emphasizes the precision of required because each layer must be perfectly aligned with previous one. After watching this video, I was amazed by how engineers use light itself to create circuits smaller than anything we can see. The precision and science behind photolithography are truly remarkable. This made me realize how multidisciplinary computer engineering really is. It combines physics, chemistry, material science, and engineering. It's inspired me to continue learning not just coding or circuits, but also science behind the machines that make our technologies possible. The fourth video is how CPU is made. Shows the journey of how a central processing unit, the brain of computer, is created from start to finish. It starts with the design phase, where engineers plan how billions of transistors will be arranged. Once the design is finalized, it is transferred onto wafers through the manufacturing process. After fabrication, each wafer contains many CPUs, which are tested to check their performance and efficiency. This video explained that not all CPUs are perfect. Some are faster than others. Those not past the highest standards are used in high-end products, while the others are used for less powerful devices. Afterward, the chips are cut, packed, and labeled ready for use in computers and other machines. This video helped me appreciate how complex and precise the CPU manufacturing process is. Every detail, from design to packaging, matters. I realized that the performance of computers depends not just on programming, but also on physical engineering behind the chips. It reminded me that the hardware and software must always work hand in hand. This understanding motivates me to become a well-rounded computer engineer who can understand both physical and digital sides of technology. The last video I watched was Future Trends of Computer Engineering Profession Top 10 Future Technologies in 2025. It presents the technologies that will shape the near future, such as artificial intelligence, quantum computing, 5G and 6G networks, blockchain, Internet of Things, robotics, augmented reality, and cloud computing. The video also emphasizes how fast technology is evolving and how future engineers need to continuously learn and adapt to these changes. These technologies will not only change industries, but also influence our daily lives, from communication, transportation, to healthcare and education. This video made me realize that being computer engineer is not just about solving problems today. It's about preparing for the technologies of tomorrow. The world is moving toward automation, intelligence, and connectivity, and we must be ready to take part in shaping that future. It also reminded me that while technology keeps advancing, we should always use it responsibly to improve human lives and create a more sustainable and connected world. After watching all these videos, I gained a much deeper appreciation of how computers and modern technologies are made, from chip manufacturing to photolithography and up to CPU creation. I saw how much science, precision, and dedication go into every stage. I also learned that chip making is one of the most complex industries in the world, requiring collaboration between many countries and experts. And as technology continues to evolve through AI, quantum computing, and robotics, the role of computer engineers will become even more important. These videos reminded me that as a computer engineer, I must be curious, adaptable, and responsible, ready to learn continuously and to use technology to help society progress. Thank you for watching my reflection video. Once again, I am Althea Torres, and this has been my reflection on the amazing world of chip manufacturing, photolithography, CPU production, and future trends in computer engineering.